Welcome to the Phenomenological Alliance channel. In this video, we will discuss the next question that phenomenology poses in the field of natural sciences, namely the problem of being focused on a model.
The phenomenon of the camera obscura has been known since antiquity. The phenomenon shows the way the image is projected onto the screen, with the presence of a small opening. When we observe an object through an opening, we see an inverted image of the object on the screen. Subsequently, the observed phenomenon will be often sketched, as shown in the picture, and used for interpretations of how light spreads behind the opening. In the corpuscular theory of light, rays of light are represented as rectilinear trajectories along which a particle of light travels. When it was noticed that there are phenomena in which light deviates from a rectilinear path, the wave theory of light was introduced. For example, the area behind the opening, where light and shadow meet, does not follow a rectilinear path of light. According to the wave theory of light, which describes the Huygens principle, each opening acts as a source of new waves, analogous to how water waves spread through space behind a breakwater. Subsequently, these two theories will be united in the representation of the photon as an energy package that possesses both the properties of a particle and a wave.
Let's pay attention to how focusing on a model can limit the perception of the phenomena. If we consider the propagation of light according to the corpuscular theory of light, taking into account that the presented model reflects reality, it remains unclear how light from a candle flame, traveling in a straight line, illuminates the candlestick and is then projected onto the screen. Although such an imprecise sketch didn't cause any major error in the theories of how light spreads through space, the sketch points to the fact that with imprecise modeling, it's easy to deviate from the facts of real life. However, the imprecise modeling of light propagation demonstrated its full significance in the wave theory of light. Because if we interpret the propagation of light according to the wave theory of light, it remains unclear how the image of the candle is imprinted in the imaginary light waves.
Phenomenology examines the structure of consciousness, and it tries to stay in the realm of phenomena. Metaphorically speaking, it is often emphasized that rather than asking why, one should inquire how. Instead of questioning why something is happening, the focus should be on understanding how an appearance became apparent. Instead of, why does light spread through space? It would be more productive to examine, how do I perceive the distant image? The first question directs focus to the model of light, potentially diverting attention from reality. The second question directs attention to reality, allowing the researcher, through the pursuit of an answer, to remain within the sphere of the actual phenomenon.
The lack of focus on reality can also be attributed to mathematical formulas. Let's consider this case examining whether light changes speed in water.